Welcome to clickmyproject.com. Let me discuss about the project Corruptive Artifact Suppression for Example-Based Color Transfer. Let me discuss about the abstract of the project. Analyzing images to estimate the underlying parameters that lead to their formation is fundamentally an inverse problem, since the observed image alone is usually not enough to uniquely determine these parameters. Statistical models are frequently used to choose a likely solution for amongst those that are consistent with this observation. In this dissertation, we use such a statistical approach to develop image models and corresponding inference algorithms for two vision application, and then explore image statistics in a new domain, a joint statistical modeling, that is JSM, in a adaptive hybrid space transform domain is reputable. It offers a powerful machinery of combining local smoothness and non-local self-similarity instantaneously to ensure a more reliable and robust assessment. A new form of minimization purposeful for solving the image inverse problem is verbalized using JSM under a regularization based agenda. The attained high determination gradient is then regarded as a gradient check or an edge preserving constraint to recreate the high resolution image. The smooth edge familiarity is a smoothness restriction. The gradient magnitudes of GPB edge directed are less stringent than those attained through our scheme and the soft cut technique. A removal of corrupted artifacts are proposed by JSM algorithm, where artifacts will be suppressed effectually and keeps local consistency. Then the result of the LSM is fed to the NLSM process, where keeps non-local consistency and restore the sharpness and edges effectually. Let me discuss about the flow diagram for our process. First, capture the input image from source file by using a getFile and mRead function. Here we need to take the corrupted artifact image from the dataset folder. Next, in the image preprocessing, user can able to change the size of the image by providing pixel height and width with the help of mRead function. Gaussian filter is windowed filter of linear class. By its nature is weighted mean. Motion filter is a apparent streaking of rapidly moving objects. Next, in the local statistical modeling for smoothness. After performed the color transfer process, we need to perform the LSM process, that is local statistical modeling, where LSM corresponds to the above local smoothness prior and keeps image local consistency, suppressing the artifact effectually. Local consistency conditions are properties of constraint satisfaction problems related to the consistency of subsets of variables or constraints. Initially, the distributed function is calculated by using generalized Gaussian distribution, Laplacian distribution, and hyper-Laplacian distribution based on the shape parameter. Finally, calculate the vertical finite difference and horizontal finite difference for obtaining the LSM result. Next, in the non-local statistical modeling for self-similarity. Non-local statistical modeling. In this, NLSM corresponds to the above non-local self-similarity prior and maintains image non-local consistency, retaining the sharpness and edges effectually. Estimate error image between input original image and corrupted artifact image, then calculate the maximum peak value of error with the histogram operation. Finally, estimate the zero mean and variance so as to can remove the artifacts effectually. Repeat this above step up to maximum iteration based on the split-Bregman iteration. The split-Bregman iteration is the repetition of the process up to maximum iteration. After obtaining the LSM and NLSM result, we combine the results with JSM, that is joint statistical modeling. The JSM is the regularization parameter which control the trade-off between two competing statistical terms. So, in order to achieve the more PSN, it will perform the SBA process. After completing maximum iteration, we obtain the artifact suppressed image, that is the resultant of artifact suppressed image. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right-click the file and run for executing this process. Here we need to select the artifact image. This is the color transfer output image. So this will be taken as an input image for our artifact removal process. And here we need to select the reference image. And here we can change the size of our input image by providing high pixel height and width. Here we need to enter the pixel height and width, and this process will be repeated for an iteration and also for 3 band. That is, our input image is a RGB image, so this process will be repeated for 3 bands, that is red band, green band and blue band. And also here I mentioned the iteration number as 2, so this process will be repeated for 2 times for every band. This will take some time for executing. After perform the 3 bands, it will provide the result. This is the resized image of our input image, and this is the red region of our input image, and this represents the green region of our input image, and this represents the blue region of our input image, and this is the artifact removal image for red band, and this is the artifact removal image for green channel, and this is the artifact removal image for blue channel, and this is the artifact removal for combined channel, that is RGB image. And this is the KL measurements, that is distance which we have calculated between input image and also artifact removal result. Here I display the KL measurement in a message box. This is the initial PSNR and this is the final PSNR we obtain after completing all the iteration. A novel algorithm for high quality image restoration using the joint statistical modeling in a space transform domain is proposed, which efficiently characterizes the intrinsic properties of local smoothness and non-local self-similarity of natural image. Thank you.